Question is this. Okay, we have to calculate the equivalent K. Okay, equivalent dielectric. So now, if we divide, okay, so the question can be solved in two. Question can be thought to be solved in two ways. Okay, so either we take all these three, K1, K2, K3 in parallel, and then we take K4 in series. Okay, or we take this, both of them to be in series, this also is in series, this is also in series, and ultimately all three of them, they are connected in parallel. Now which one to take, or can we take both of them? So actually we cannot use this. We'll get a wrong answer. Why? If you see, when we tell that this is in, like these all are in parallel, when we tell, so what we are assuming is that if this was at V1, okay, this was at V2, so what we are assuming is that this is at the same potential V. Okay, because all are in parallel, so that means they must have been connected across the same potential. But this is not correct. This is not going to be correct. Why? You see, potential difference is equal to electric field, okay, into, so we have this, minus dV is equal to E dot dr, okay, or dV equals minus or E dot dr. So potential difference is equal to electric field into the distance. Now the electric field gets modified by placing the dielectric. So if suppose, like in a simple example, if let us say, the electric field was E naught before, now we have placed a dielectric here. Okay, so then the electric field will become E naught upon K. Okay, the dielectric changes the electric field. So if the electric field, so if the potential is same, that means we are telling that the electric field is going to be the same. E into d by 2 should be equal to V1 minus V. So if you see, electric field remains the same, but no, this is not the case. Electric field will not be the same in all three of them, so therefore the potential will be different. And due to the change in potential being different, so we cannot take this to be in parallel. Okay, this has to be very clear. Okay, so now why we can take this? So here, yes, we can take this because you see, the the electric field, whatever, like let us say E1 is the electric field, E1 into d by 2, and here let us say the electric field is E4, so E4 into d by 2. So this is the change in potential, and this should be equal to the, like here potential is V1, here potential is V2, here potential is V. So here this, both of them, they should add up, and the change in potential should be V1 minus V2. For this there is no doubt for all of the three. So therefore this is not going to work. Okay, and in fact what is going to happen here is basically here little strange, okay, but we have to be clear about this. Here there is going to be different, at all the three there is going to be different surface charge density, because now things have to be adjusted, electric field has to be adjusted. So here sigma 1, sigma 1 by epsilon naught, okay, into d by 2, okay, and of course K1 is also here, okay, so K1, and plus again sigma 1 by K4 into epsilon naught into d by 2. This should be equal to the total potential change. Okay, what is sigma 1 by epsilon? This is the electric field. Okay, so this should be the change in potential. So here it should be sigma 1, here it should be sigma 2, here should be sigma 3, because we have K1, K2 and K3 all are different. Okay, so this is ultimately what is going to happen. Although the plate is same, still the surface charge density will be different for different sections. Okay, and we cannot use all of them in parallel and like that. So the first approach we cannot use. Now let us solve this. So this is how we have to do it. So K1 and K4 are in series. Okay, so for this, what is the capacitance? So capacitance is epsilon naught into K1 into, now area of cross section, area of the plate. This is divided into 3, so therefore this is A by 3. So therefore A upon 3 divided by, now the distance between the two plates is D upon 2. So therefore D upon 2. Okay, so this becomes so whatever, we will do this. So now this is connected in series with this. Okay, what is the capacitance here? So this C1, C4. So here the capacitance is epsilon naught K4 into A by 3 divided by D upon 2. So therefore the equivalent capacitance here is going to be 1 upon C is equal to D upon 2 divided by epsilon naught K1 into A by 3 plus again D upon 2 epsilon naught K4 into A upon 3, which becomes 1 upon C is equal to D by epsilon naught A. Of course, D by 2 and A by 3 is, so 3 goes up. So this is 3D by 2 epsilon naught A, 1 by K1 plus 1 by K4. So therefore the capacitance becomes here. So this is basically K1 into K4 divided, and K1 plus K4 is in the numerator. So therefore the capacitance is 2 epsilon naught A K1 K4 divided by K1 plus K4. Now this is for this. Now here it will be K2 K4 by K2 plus K4, and here it will be same thing into K3 K4. Okay, so now since all of these are in parallel, now we add up. Okay, so plus K2 K4 by K2 plus K4, and of course 3 epsilon naught A is also there. Sorry 2 epsilon naught A divided by 3D is there. Okay, 3D is there. So this plus K3 into K4 by K3 plus K4, and now this entire thing should be equal to epsilon naught A by D into K equivalent, because what is being said is, if a single dielectric material is we remove everything and single dielectric material is replaced. Okay, so epsilon A by D is gone. So K equivalent equals 2. Now K4 is taken as common, so 2 K4 by 3 into K1 by K1 plus K4 plus K2 by K2 plus K4 plus K3 by K3 plus K4. So therefore the answer is going to be